Um, hi guys. Hi guys. Today I will introduce some academic papers that explore the fascinating world of large language models and their applications in various domains. And these papers showcase groundbreaking research that pushes the boundaries of what LLMs can do, from enhancing visual tasks to improving mathematical problem solving, from fine-tuning models to understanding human reasoning. We'll also delve into how LLMs can be used in legal entity classification, music creation, dialogue inference, and even finding reliable information online. Get ready to be inspired by the innovative ideas and practical solutions presented in these papers. Let's dive in. At the paper that frozen transformers in language models are effective visual encoder layers, explores whether large language models, or LLMs, can be used for visual tasks without relying on language. The authors discovered that incorporating a frozen transformer block from a pre-trained LLM as a visual encoder layer greatly improves performance across different visual tasks. They also propose the information filtering hypothesis to explain why pre-trained LLMs are effective in visual encoding. This research is important because it shows that LLMs can be used for more than just language tasks, opening up new possibilities for artificial intelligence. The paper AutoMix introduces a clever solution to a problem faced by large language models. These models have many options to optimize their performance, but it can be challenging to use them effectively. AutoMix proposes a method called Q-shot self-verification, which estimates the reliability of a smaller language model's outputs without needing training. It also introduces a meta verifier to improve the accuracy of these assessments. Additionally, the paper introduces a metric called incremental benefit per cost, second-ware IBC, to measure the efficiency of integrating smaller and larger language models. So overall, AutoMix offers innovative ways to make language models more efficient and accurate. The paper SEGO introduces a framework that helps large language models, LLMs, solve mathematical problems more effectively. It addresses the problem of enhancing the problem-solving capabilities of LLMs in mathematical tasks. The main contribution of the paper is the SEGO framework, which establishes a connection between breaking down problems into smaller sub-goals and the probability of solving them. SEGO generates problem-specific sub-goals and optimizes them based on certain criteria. By incorporating these optimized sub-goals into the training of the LLM, its problem-solving performance is improved. In simpler terms, SEGO helps LLMs become better at solving math problems by breaking them down into smaller steps and optimizing the way they approach each step. The paper transformer-based entity legal form classification addresses the challenge of accurately classifying different types of legal entities based on their names. This is important for financial and business processes. The authors propose using transformer-based language models, specifically BERT variants, to improve the classification accuracy. They compare these models with traditional text classification approaches and show that the transformer models perform better. The models are also validated through an expert review process in 10 different jurisdictions, confirming their accuracy. The paper highlights the potential of transformer-based models in improving data standardization and integration, which can benefit financial institutions, corporations, governments, and other organizations. The paper, The Shifted and the Overlooked, is about how researchers are studying conversations between users and AI language models to better understand the needs of real-world applications. They found that there's a difference between what users ask and what traditional NLP benchmarks focus on. The paper suggests that tasks like giving advice, designing, and planning are often overlooked in current research. The authors propose using a new version of the language model called GPT-4 to analyze user queries and identify these overlooked tasks. And this research is important because it helps make AI language models more useful and aligned with what people actually need. The paper Loop Copilot introduces a new system that helps people create music using artificial intelligence. It addresses the problem of existing AI music systems being limited in orchestrating different parts of music and not allowing for changes and improvements during the creation process. The paper's main contribution is the development of Loop Copilot, which allows users to generate and refine music through a conversation-like interface. And it also introduces the global attribute table, which helps keep the music consistent and connected throughout the editing process. The paper's findings were evaluated through interviews and questionnaires. And overall, Loop Copilot is an important innovation in AI music creation. The paper Illuminating Reasoning via Inferring with Planning introduces a new way to help large language models, or LLMs, think more like humans. And so the problem is that current methods only focus on linear thinking and don't capture the complexity of human cognition. The paper proposes a framework called inferential exclusion prompting, IEP, that combines elimination and inference to guide LLMs in thinking non-linearly. This means that LLMs can plan and use natural language inference to figure out the best answer based on the given context. But it was an additional term that all those papers, if you do see the similar set to have much of the similar settings, this paper is important because it helps LLMs become better at reasoning and understanding language. The paper, An Emulator for Fine-Tuning Large Language Models Using Small Language Models, introduces a new approach called emulated fine-tuning to understand the capabilities of large language models. The authors show that scaling pre-training improves factuality, and while scaling fine-tuning improves helpfulness. They also demonstrate that EFT allows for dynamic adjustment of behavioral traits without additional training. Additionally, they propose model upscaling, which combines a small fine-tuned model with a large pre-trained model to approximate the benefits of fine-tuning a large model without the computational expense. And overall, this paper provides valuable insights into the potential of large language models and offers practical solutions for improving their performance. The paper AgentTuning introduces a method called AgentTuning that aims to improve the abilities of language models while maintaining their general capabilities. The authors address the lack of research in this area and propose a solution by constructing a data set called AgentInstruct, which contains high-quality interaction trajectories from various agent tasks. They also combine this data set with general domain instructions to create a hybrid instruction tuning strategy. By fine-tuning the language models using AgentTuning, they create agent LM models that show improved performance compared to previous models. This paper is significant because it enhances the abilities of language models in understanding and generating instructions, which can have various applications in real-world scenarios. The paper Model Merging by Uncertainty-Based Gradient Matching addresses the problem of inaccuracies in model merging methods. Model merging is a process where multiple models are combined to create a more accurate model. However, existing methods that use weighted averaging often result in inaccurate merged models. The authors of this paper propose a new method called uncertainty-based gradient matching to improve model merging. This method focuses on reducing the mismatching gradients between the models being merged. And paper also reveals the assumptions made by existing merging schemes and provides a new method that consistently improves performance and robustness. And overall, this paper contributes to the field of model merging by providing a more accurate and reliable method. The paper Survival of the Most Influential Prompts is about making large language models smarter and more efficient. It focuses on a technique called prompt search, which helps these models generate better responses. The paper introduces a method called CLACS, which clusters and prunes the search space to find the most important words for generating prompts. By doing this, CLACS reduces the time and effort needed to search for the best prompts. The paper shows that CLACS outperforms other methods and improve the performance of language models across different tasks. What it is that it's important because it helps us make language models travel smarter and more cost-effective. The paper Large Language Model for Multi-Objective Evolutionary Optimization introduces a new approach to solving complex optimization problems. It addresses the challenge of designing search operators for multi-objective evolutionary algorithms, MOEs, that typically require manual design and domain knowledge. The authors propose using large language models, LLMs, as black box search operators for MOEAs. They demonstrate the effectiveness of this approach by designing a decomposition-based MOEA framework called MOEA BLOW. Additionally, they introduce an explicit lightbox operator with randomness to interpret the behavior of LLMs. This innovative approach simplifies the design process and improves the efficiency of optimization algorithms. The paper Contrastive Learning for Inference in Dialogue addresses the challenge of understanding and generating inferences in dialogue. It focuses on the difference in information between the context of a conversation and the desired inferences. The authors analyze this information gap and propose a contrastive learning approach to bridge it. This approach helps improve the generation of inferences by training models to contrast different dialogue contexts. The paper also provides data annotation based on the information gap and assesses the difficulty of the inference generation task. Overall, this research contributes to enhancing our understanding of dialogue inference and offers a valuable approach to improve inference generation and conversations. So the paper Nowhere to Go addresses the challenges of validating the reliability of search results and the credibility of online sources. It proposes a framework that uses large language models to generate relevant and trustworthy sources, verify their reliability, and refine unreliable sources. The paper introduces several innovative ideas, such as intent-based query expansion, constrained online source generation, evidence-sensitive validation, and multi-strategy supported optimization. These ideas, they help improve the relevance, responsibility, and trustworthiness of search results. The paper's contribution is significant as it provides a solution to the problem of finding reliable information on the internet, which is important for everyone, including 10-year-old children. Okay, that's all for today. In today's session, we explored various papers that showcased the versatility and potential of large language models. We learned how LLMs can be used for visual tasks, music creation, mathematical problem solving, legal entity classification, reasoning, optimization, dialogue inference, model merging, and information retrieval. These papers highlight the advancements in LLMs and their applications across different domains, making them smarter, more efficient, and aligned with real-world needs. Okay, that's all for today. If you enjoyed my video, I'd appreciate if you could give it a thumbs up and subscribe to my channel. Your support helps me create more content. Thank you. See you next Monday.